See, now shall see the classification of colloidal systems based on type of dispersed phase. In fact, on the basis of this, colloids or salts are classified into three types. One, multimolecular colloids. Second one, macrocolloids or polymer colloids. Then another one is micelles or associated colloids. Now, let us see these three types of colloidal systems. See, multimolecular colloids are those colloidal systems. They are formed by using substances in which particle size is less than 1 nanometer. Actually, this type of salts are prepared from the substances in which particles, say molecules, atoms, etc., which have the size less than 1 nanometer. During the formation, such particles undergo association, aggregation to form colloidal system. Say, any type of systems can be brought into colloidal state. That is, true solution or crystalloids can be brought into colloidal state by association of particles of the system. As the result, size of the particles increases from 1 nanometer to above. See, this one based on that. In this case, small particles undergo association to form a corresponding colloidal system. Such colloidal systems are known as multimolecular colloidal systems or salts. Example for this, sulfur salt, that is milk of sulfur, gold salt, silver salt, etc. They are considered as multimolecular colloids. They are formed by the association or aggregation of particles. Next, macro or polymer colloids. This type of colloids or colloidal systems are formed by breaking the particles of substances, of course, which have the size greater than or 10 to the power 1000 nanometer. See, particles which have size greater than 1000 nanometer. Such particles or system on breaking, colloidal system forms. Such colloidal systems are known as macro or polymer colloidal systems. That is, this type of salts are prepared by breaking the particles. This type of salts are prepared by aggregating, association of particles method. Example here, cellulose, nylon, some polymers, of course, cellulose, nylon, and polyethylene, proteins, etc. They come under this type of category. Next one is associated colloids or micelles. Associated colloids or micelles. One important type of colloidal systems. See, it is observed that solution, very dilute solutions of some substances, particularly soaps and detergents, very dilute solutions of some substances behave as strong electrolytes. That is, at very, very low concentration, solution of some substances behave as true solution, of course, behave as strong electrolytes. On the other hand, on increasing the concentration, at one concentration level or above that, the system behaves as a colloidal system, SOL. Such type of colloidal systems are known as associated colloids or micelles. It is observed in the case of soap and detergent solutions. See, micelles or this type of colloidal system are formed at one particular concentration level or above that. Below that concentration, micelles or associated colloids will not be formed. The concentration of solution above which micelles are formed is known as critical micelle concentration, CMC. CMC means critical micelle concentration. It is the concentration of the solution above which solution or system behaves as salts, colloidal system, below which behaves as true solution or strong electrolytes. And to form micelles, temperature also plays an important role. So micelles are formed at one particular temperature or above that temperature. The temperature above which micelles formation takes place is known as Kraft temperature. Known as Kraft temperature, denoted by Tk. So these two are important terms: critical micelle concentration (CMC) and Kraft temperature. Critical micelle concentration means it is the concentration of the solution above which solution acts as salt, below which it simply acts as a true solution or strong electrolytic solution. Kraft temperature, once again, it is the temperature above which micelles formation takes place, below which micelles formation not occur. Now, let us see the way of formation of micelles. And what are micelles? See, soaps and detergents normally form this type of colloidal system. You know, soap. Soap is sodium or potassium salt of fatty acids, long chain, carbon chain acids. See, generally soap can be written as or represented as RCOO, Na or potassium K, that is RCOO-K or RCOO-Na, that is sodium or potassium salt of fatty acid. Here R is a long carbon chain group, COO carbonic acid group, and of course it is a salt, carboxylic acid salt. So here the soap in solution dissociates to form RCOO minus and Na plus. This RCOO minus is generally known as carboxylate ion. So soap in solution first dissociate to give RCOO minus, that is carboxylate ion, or you can say anion and metal ion. Next, here you just see RCOO minus. Here it has two parts. One is alkyl part or side chain part. Another one is COO, carboxylate group. Here lies one interesting thing. This COO minus end, that is carboxylate end, is water loving end, that is hydrophilic end, whereas this one R, it is water repellent or water repelling group or end. So this is hydrophobic. So carboxylate ion of soap has two parts. One is hydrophilic part consisting of COO minus group and hydrophobic part, that is long chain alkyl group or even aryl group. See, when you put a very little amount of soap in water, where concentration of that soap solution is very, very low, first soap ionizes like this to form this carboxylate ion. In solution, there are very less number of carboxylate ion. Number of carboxylate ion is very, very small. In such case, that is, this is water. It is under low concentration, under very low concentration. See, number of RCOO ion present is very less, and here in the solution, this COO minus end projecting towards water, whereas R end projecting towards space, above the surface. That means here it is hydrophilic, hence it moved toward water. It is hydrophobic, move away from water. The situation can be written like this: RCOO minus. This is the situation of soap solution in very low concentration or dilute condition. Now, if you increase the concentration, see, under this situation, micelles are not formed. Micelles are not formed because concentration is very low. On rising the concentration, on increasing the amount of soap in water, in given amount of water, number of RCOO group is increased. When number of RCOO group increased, the situation rises like this. See, this COO and carries negative charge. When number of RCOO group increased in the system, there develops the repulsion between COO groups. Repulsion develops between COO groups of different RCOO ions. As the result, the COO group move away from each other. At the same time, R groups come closer with each other. That is like this: R O sorry. Like this. The R groups come closer to each other because the COO groups carrying same charge repel or move away from each other. Thus, an spherical ionic atmosphere is formed in the system. This type of spherical ionic atmosphere is formed in the system. This spherical ionic atmosphere formed in the system is known as micelle or micelles. Okay, this is the way of formation of micelles in solution. To form micelles in the solution or system, the concentration of the system should be above its CMC, critical micelle concentration, and temperature should be above Kraft temperature. And of course, it varies from, of course, these two vary from one substance to another substance, one type of soap to another type of soap. This is important one, that is a way of formation of micelles in the solution of soap or system of soap solution. Next bit is, you know, soaps are generally used as cleansing agent. That is, soap is generally used for washing purpose. Now let us see the cleansing action of soap. How soap acts as a cleansing agent. How it removes dirt, oil, grease, etc. from the fiber or clothes. That is another important thing. Now, take soap solution, concentrated soap solution. You know, concentrated soap solution contains large number of micelles. So, in the solution, if micelles are present, then only it will act as cleansing agent. So, it is possible only in the case of concentrated solution. In dilute solutions, micelles normally do not exist, form. Hence, such solutions will not act as cleansing agent. See, take soap solution, concentrated soap solution. Now, concentrated soap solution contains large number of micelles. When you put a dirt cloth, that is cloth containing oil, grease and rubbish things. When you put the dirt cloth in soap solution, you know, micelles have two ends. One R end, another this COO minus end. Okay. When you put dirt cloth in soap water or soap solution, this R end attracts the oil, grease, rubbish thing present in the cloth, and this R group or R end links to dirt of cloth. So, R adhere or stick to the dirt. This COO end actually move towards water. Actually, COO, it is hydrophilic end. Hydrophilic end, COO minus, move toward water. As the result, this R group linked to the dirt also move towards water. Okay. While moving, the dirt is removed from the cloth or fabrics. This is the way how soap acts as cleansing agent. On soaking or on dipping the cloths several times in soap water, the dirt is completely removed from the cloth. This is how soap acts as cleansing agent. ನಾವು ಮನೆಯಲ್ಲಿ ಒಂದು ಇದು ಮಾಡ್ತೀವಿ, ಈ ಸೋಪ್ ಚೆನ್ನಾಗಿಲ್ಲ, ಕೊಳೆನೇ ತೆಗೆಯಲ್ಲ ಅಂಥೇಳಿ, ಈ ಸೋಪಲ್ಲಿ ಕೊಳೆ ಹೋಗಲ್ಲ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಟ್ ಈಸ್ ಇನ್ಫ್ಯಾಕ್ಟ್ ಎ ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಐ ಫೀಲ್. ಯಾಕೆಂದರೆ ಆ ಸೋಪ್ ಕೊಳೆ ತೆಗಿಬೇಕಾದ್ರೆ ಆ ಸೋಪ್ ಅದರ ಸೊಲ್ಯೂಷನ್ ಮಸ್ಟ್ ಬಿ ಇನ್ ಇಟ್ಸ್ CMC ಆ್ಯಂಡ್ ಕ್ರಾಫ್ಟ್ ಟೆಂಪ್ರೇಚರ್ ಆರ್ ಎಬೋವ್. ಅದರ ಕ್ರಿಟಿಕಲ್ ಮಿಸೆಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಷ್ಟು ಇರಬೇಕು ಸೊಲ್ಯೂಷನ್. ಆ ಕಾನ್ಸಂಟ್ರೇಷನ್, ಆ ಸ್ಟ್ರೆಂತ್ ಇದ್ದರೆ then only it will act as cleansing agent, because that solution contains large number of micelles. ನಾವು ಸೋಪೇ ಜಾಸ್ತಿ ಹಾಕಿದೇನೆ ನೀರಿಗೆ, 2 ಬಕೆಟ್ ನೀರಿಗೆ ಒಂದು ಅರ್ಧ ಸ್ಪೂನ್ ಸೋಪ್ ಹಾಕ್ಬಿಟ್ಟು ಅದ್ರಲ್ಲಿ ಬಟ್ಟೆ ಕೊಳೆ ತೆಗಿ ಅಂದರೆ ಇಟ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ಗೊತ್ತಾಯ್ತಾ? ಯಾತಕ್ಕೆ ಆ ಸೋಪ್ ಸೊಲ್ಯೂಷನ್ ಕ್ಲೀನ್ಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿ ಆ್ಯಕ್ಟ್ ಮಾಡಲ್ಲ ಅಂದರೆ ಅಲ್ಲಿ ಮೀಸೆಲ್ಸ್ ಫಾರಮ್ ಆಗಿರಲ್ಲ, ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ನಾಟ್ ಸಫಿಷಿಯೆಂಟ್ ಟು ಫಾರಮ್ ದ ಮೀಸೆಲ್ಸ್ ಆರ್ CMC ಲೆವೆಲ್ನಲ್ಲಿರಲ್ಲ, ಆದ್ದರಿಂದ ಅದು ಕ್ಲೀನ್ಸಿಂಗ್ ಏಜೆಂಟಾಗಿ ಆ್ಯಕ್ಟ್ ಮಾಡಲ್ಲ. ಸಮ್ಟೈಮ್ಸ್ ಸೋಪ್ ಸೊಲ್ಯೂಷನ್ ಫಾರ್ಮ್ ಮಾಡುವಾಗ ಹಾಟ್ ವಾಟರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಈ ಸೋಪ್ ಪೌಡರ್ ಡಿಸಾಲ್ವ್ ಮಾಡುವಾಗ ಸಮ್ಟೈಮ್ಸ್ ಹಾಟ್ ವಾಟರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಹಾಟ್ ವಾಟರ್ ಯೂಸ್ ಮಾಡೋದು ಏಕೆಂದರೆ ಜಸ್ಟ್ ಟು ಕೀಪ್ ದ ಸೊಲ್ಯೂಷನ್ ಅಟ್ ಕ್ರಾಫ್ಟ್ ಟೆಂಪ್ರೇಚರ್. ಆ ಟೆಂಪ್ರೇಚರ್ಗೆ ಬಂದಾಗ ಫಾರ್ಮೇಷನ್ ಆಫ್ CMC ಮೀಸೆಲ್ಸ್ ತುಂಬ ಈಸಿ ಇರುತ್ತೆ. ದಟ್ಸ್ ಆಲ್ ಅಬೌಟ್ ದ ಕ್ಲಾಸಿಫಿಕೇಷನ್ ಆಫ್ colloidal systems, that is, one on the basis of physical states of dispersed phase and dispersion medium, another one on the basis of affinity of dispersed phase towards dispersion medium, next one on the basis of type or nature of dispersed phase. Now, let us see the methods of preparation of colloidal systems. Once again, I wish to say, colloidal systems or colloids can be prepared by breaking the big particles. That means by dispersion method or by aggregation method, but that is by union of small particles, association of small particles. So methods of preparation of salts based on these two things. See, there are number of methods to prepare colloidal systems. One, chemical method. Another one, electrical method. Next one, peptization method. On the point of your examination, electrical method and peptization method are important. Now let us see some chemical methods of preparation of salt. Salts can be prepared by carrying out some chemical reactions, that is by oxidation method, reduction method, hydrolysis method, double decomposition method, so on and so forth. Now let us see some examples of chemical methods of preparation of salt. Pass hydrogen sulfide gas. Hydrogen sulfide gas, ನೋಡಿರಲ್ಲ, ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೈಡ್ ಗ್ಯಾಸ್ ರಾಟನ್ ಎಗ್ ಸ್ಮೆಲ್ ಇರುತ್ತೆ. ಲ್ಯಾಬಲ್ಲಿ ನಾವು ಪ್ರೊವೈಡ್ ಮಾಡಬೇಕು. ನಿಮ್ಮ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಸಾಲ್ಟ್ ಅನಾಲಿಸಿಸಲ್ಲಿ ಸ್ಟಿಲ್ ಪ್ರೊವೈಡ್ ಮಾಡಲ್ಲ ಯಾವ ಇದರಲ್ಲೂ, ಆದ್ದರಿಂದ ನಿಮಗೆ ಅದರ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗಿರಲ್ಲ. ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೈಡ್ ಸ್ಮೆಲ್ ಏನಿರುತ್ತೆ? ರಾಟನ್ ಎಗ್ ಸ್ಮೆಲ್. ರಾಟನ್ ಎಗ್ ಸ್ಮೆಲ್ ಏನಿರುತ್ತೆ, ತುಂಬ ಪ್ಲೆಸೆಂಟ್ ಆಗಿರುತ್ತಲ್ಲ. ರಾಟನ್ ಎಗ್ ಸ್ಮೆಲ್ ಅಂದರೆ ಏನು, ಕೋಳಿ ಮೊಟ್ಟೆ ವಾಸನೆ ಅಂತ, ಅಷ್ಟು ಕೆಟ್ಟದಾಗಿರುತ್ತೆ, ಫೌಲ್ ಸ್ಮೆಲ್ ಇರುತ್ತೆ H2Sಗೆ. ಸಿ ಪಾಸ್ H2S ಗ್ಯಾಸ್ ಥ್ರೂ sulfur dioxide suspended in water. Sulfur dioxide dissolved in water. When you pass H2S through sulfur dioxide solution, here sulfur is, sol of sulfur is formed along with H2O. Okay. Sulfur sol is formed, yellow color, pale yellow color. Sulfur sol is formed, which is also known as milk of sulfur. See, this is one method of preparation of, chemical method of preparation of salt. Now, another method is there. Take gold chloride, auric chloride, treat it with HCHO. What is HCHO? Formaldehyde, that is methanol. Formaldehyde solution. When you treat gold chloride with formaldehyde solution, gold chloride is reduced to form colloidal gold along with the formation of formic acid and HCl. This will be in the form of salt, that you will get gold salt. In the salt, gold particles, fine gold particles, colloidal gold particles are present. This is one method, that is reduction method. First one you can consider it as oxidation method. Another one is hydrolysis method. Take ferric chloride solution. Take ferric chloride solution and add few drops of ferric chloride solution into boiling water under boiling condition. Pour 1 or 2 ml of ferric chloride solution into boiling water. Hydrolysis takes place to form a red sol of ferric hydroxide. Red sol of ferric hydroxide. This is hydrolysis method. Take As2O3, arsenic oxide solution, that is arsenic oxide suspended in water. Through this, pass H2S gas. When you pass H2S gas through arsenic oxide solution, here As2S3, arsenic sulfide salt is formed along with, of course it is salt, along with H2O. Okay, these substances formed are in the colloidal state. There is salts. These are some examples for the preparation of salts by chemical method. Another one we can give, that is gold chloride when treated with stannous chloride. Here reduction takes place, or you can say double decomposition, to form gold along with stannic chloride. Gold chloride reduced to stannous chloride converted into stannic chloride. This is also a method of preparation of salt, that is by chemical methods. Next method is very important on the point of your examination, that is peptization method, also something like chemical method. Peptization method. What is this peptization method? See, precipitate normally in solid form. Precipitates can be seen through our naked eyes. Porous suspension or suspensionoid state ಅಲ್ಲಿ ಇರಬಹುದು. Take a precipitate, say ferric hydroxide precipitate. Ferric hydroxide precipitate. Here you can see the particles even through your naked eyes. You can convert this precipitate into salt, that is ferric hydroxide salt. See, to convert precipitate into salt, you have to break the particles. You have to reduce the size of the particles into colloidal dimension or state. This can be carried out by making use of a suitable electrolyte. If you add a suitable electrolyte into the precipitate and shake it well, the electrolyte used must contain an ion of the precipitate. The electrolyte must contain an ion of the precipitate. That's why we used to say suitable electrolyte. Here, if you add ferric chloride, little amount of ferric chloride into ferric hydroxide precipitate, little amount of ferric chloride solution into ferric hydroxide precipitate and shake it well, this precipitate is simply converted into salt. Before that, you can see the particles present in this case. After shaking it with ferric chloride solution, little amount of ferric chloride solution, you can't see the particles of ferric hydroxide because the particles will be in the colloidal dimension. Colloidal state ಬಂದ್ಬಿಟ್ಟಿರುತ್ತೆ. ಇಲ್ಲಿ ಬರೀ ಕಣ್ಣು ಕಾಣಿಸ್ತಿರುತ್ತೆ, ಇಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ಸ್ ಕಾಣದೇ ಇಲ್ಲ ಬರೀ ಕಣ್ಣಿಗೆ. However, you can see the particles under ultra microscope. Salt form ಆಗಿರುತ್ತೆ. This method of conversion of precipitate into salt by making use of a suitable electrolyte. That means electrolyte containing an ion common with the precipitate. You can add ammonium hydroxide also here. So, ferric hydroxide precipitate is converted into ferric hydroxide salt. Process is known as peptization. The electrolyte used to convert the precipitate into salt is known as peptizing agent, peptizing agent. So, this is an important method. See, you just take silver iodide precipitate. Okay, yellow color precipitate, of course. You convert this precipitate into salt, silver iodide salt. What else you have to do? You have to add a suitable electrolyte. Suitable electrolyte means electrolyte containing an ion of the precipitate. This precipitate has two ions. One is silver ion, another one is iodide ion. To convert this silver iodide precipitate into silver iodide salt, you can add an electrolyte having either iodide ion or silver ion. So, you can add silver nitrate solution, little amount of silver nitrate. The silver nitrate contains silver ions common with silver iodide. Or you can add potassium nitrate also. Potassium nitrate contains, potassium iodide. Potassium iodide contains iodide ion, which is common with silver iodide. On shaking silver iodide precipitate with a solution of either silver nitrate or potassium iodide, precipitate is simply converted into salt. Here you can say silver nitrate or potassium iodide act as peptizing agent or peptizers in the conversion of silver iodide precipitate into silver iodide salt. This is about peptization method of preparation of salts. Next one is electrical method of production of salt. That is also very important on the point of your examination. That is Bredik's arc method. Bredik's arc method or electrode dispersion method. See, by this method one can prepare metal salts. Metal salts, keep it in mind, normally metal salts are hydrophobic salts, lyophobic salts. Okay, you can prepare metal salts, say gold salt, silver salt, copper salt, etc. by this method. To prepare metal salt by this method, first take 2 wires of a metal whose salt to be prepared. ಯಾವ ಸಾಲ್ ಪ್ರಿಪೇರ್ ಮಾಡಬೇಕು ಅಂತಿರ್ತೀರೋ ಆ ಮೆಟಲ್ನ 2 ವೈರ್ ತಗೊಳ್ಳಿ. If you want to prepare gold salt, take 2 gold wires. Okay. Now place one end of these 2 wires in a beaker containing suitable solvent. Here suitable solvent is water along with a little amount of KOH. Here it is solvent plus KOH, potassium hydroxide. The purpose of using potassium hydroxide is to increase the stability of salt formed. That is important one. Purpose of using potassium hydroxide in the Bredik's arc method, potassium hydroxide or even sodium hydroxide, is to increase the stability of salt and also to increase the conductivity. Okay. So take 2 wires of a metal whose salt to be prepared. Then place their one end in a beaker containing suitable solvent, say water along with potassium hydroxide. Keep these 2 wires ends very close to each other, but they should not touch with each other. Then place this beaker in a freezing bath. This is freezing bath, that is salt ice bath. Okay. Next, connect these 2 wires to a high current source. High current source. Now pass high current through these 2 wires to form an electric spark. Just create or form an electric spark. What is this? Arc or this one? Electric spark or arc. Struck an electric spark between the 2 wires in the solution by passing a high current density or high current. Because of high temperature of this spark, a part of this metal, that is wire or electrodes, vaporize. Then vapors are condensed in the liquid phase to form salt. Okay. So if you use gold wires, you will get gold salt. Copper wires, copper salt. Okay. This is one important method. Of course, this method is known as Bredig's work method. Once again, I repeat. To prepare metal salt, take 2 wires of that metal. Place one end of the wires in a beaker containing little amount of suitable solvent along with KOH. Purpose of using KOH here is to increase the conductance as well as stability of the salt formed. Then place this beaker in a freezing bath. Then connect the 2 wires to a high current source. After that, struck an electric arc between the 2 electrodes or 2 wires by passing high amount of current. Because of high temperature of the spark formed, a part of the metal vaporized, that means wire vaporized, and vapors are condensed in the liquid phase in the form of salt. That is. So, these are some methods of preparation of salts. In the next class, we shall see the purification of salts. Okay, thank you.